We are going to solve deepest leaves sum problem. This problem is classified as a medium problem, but I think it's easier. So let's talk about the problem. It says we are given a binary tree and we are needed to return the sum of the values of its deepest leaves. So when we start from the root, we are just going to go to the deepest level, which is here the level which 7 and 8 belongs to. So, and we are going to return the value of the sum of the nodes here. So this is our input and the output is 15 apparently. So also we are given to the power 4 nodes and between 1 and 100 the values. So we can use integers. This represents that because it will take at most 10 to the power 6 as a value. And what we can do is, in this problem, we can just traverse the tree starting from the root, and we can determine which level is the deepest level or the highest number that represents the level, and we can traverse the tree again to sum the values on that level. We cannot do it in one traversal as far as I think, because when we start from the root, when we reach to a leaf node, we do not know if it is the deepest level or not in our first traversal, right? So we cannot take 5 here, apparently, because it is not in the deepest level. So let's start coding it. Let's just first check if root exists. If it doesn't exist, we are just going to return 0, because that's the answer. And what we can do after this is, let's initialize a variable max L, which is going to be integer minimum. This is going to represent the deepest level, so that's why it's max L. And we need what we need the current level, which is 0, and we can use BFS. So let's use a queue. But this queue will take not only the tree node, it will also take the level itself, so that we can count. What we can do to achieve that is we can use a pair. So it's going to be a tree node pointer and an integer. And let's call this Q. And we are going to push this pair here, which is going to be root and L. We can just push 0 here. Actually, we do not even need to use this. Okay. So let's implement the BFS. So if the queue is not empty, what we are going to do is we are just going to take the top value, which is going to be in the kind of this. Let's call that front F, and it is of course the front of the queue, and we are just going to pop the queue's front because we don't need that anymore. And at this point we can just analyze if we can update the value of the max L, which is going to be the maximum of itself, and the value on the second part of the pair, which is the level, right? So we are determining the deepest level with this line, and after that we are just going to move on with our BFS. So if our node has a left child, how can we determine that? We are just going to use f dot first left. So our current node is this one, and if it has a left child, we are going to push that to our queue, which is going to be like this. We are just going to push a pair. The first part of the pair is of course this element, which is a tree node, and the second one is going to be the this thing plus 1, because this thing represents the level, so we are getting one level deeper. We are just going to do the same thing for the right hand side. Sorry, we're just going to do the same thing for the right hand side. It's going to be right, it's going to be right, and yeah. After this point, what we are going to do is we are just going to finish the BFS, because after this while loop, we already know the deepest level. So we are just going to repeat this thing to just find the answer. So let's call this second Q QQ. It doesn't necessarily matter. And this is going to, of course, 0 because we do not have something called L. Otherwise, it will give us an error. Let's just make all of this QQ. And what we are going to do is we are just going to check if our level, which is f.second, is equal to max L, because we already calculated it. We do not need this line. And if we kept that line, it wouldn't change anything in this thing, because max L is already the deepest level. So if we have f.second is equal to max L, what's going to happen is we are just going to take the values and add it to answer. So answer plus equals to f.first value, because this current node is on the deepest level. At the end, what we are going to do is we are just going to return answer. So let's see if this works. Yeah, we have an answer problem. Yeah, because we did not initialize the variable. We did not even define it. So our output is incorrect, apparently. Let's see what's the problem. So we pop here, and second here. So let's see what is the value of the max L, right? It should be 0, 1, 2, 3 in this case. So it returns us 0. Why? f.second starts with 0, and yeah, because we made a grave mistake here. It should exist, not non-existing. So in the second case, this is also going to change, and I think this will work. Yeah, let's submit it and see if this works for all the cases. It works. So let's talk about time complexity and space complexity without spending much time. So apparently we are using two BFS, so a constant time BFS, and our BFS is on a tree, which means it is going to take ON time. So O2N, which is going to be equal to ON asymptotically. What about space? Also our space, it keeps just at most n elements in the order of n. So what's going to happen is it's going to be ON space and ON time. So thank you for watching.